The history of cod fishing in Iceland dates back to the Viking era. Around 847 AD, Norse began migrating from Europe into Iceland. Since then, fishing has become a major part of the sustainability of Iceland along with their geotherms. Now, in modern era, not only is fish used for eating, but new advances have been made to use the fish to actually heal wounds, specifically the fish skin. We're going to find out next in a minute. Hey, this is Dr. Ben Pearl. I am here with Gunnar Johansson. He is a scientist from Iceland, and he's going to talk to us about how you can use fish skin to help with some very, very difficult wounds to heal. Now, one of the points I wanted to bring up for the physician community and for the patient community is there is a lot of disinformation that is out there regarding different animals that we use to help heal wounds, different products from humans that we help to heal wounds. So he knows the real deal. He's done the research. Tell us a little bit about it.
Yeah, thanks for having me on, Doctor, and love being here. This is a topic very near and dear to me. So one of the things that we've been seeing is, like, of course, in the market, there's so many different products with different processing methods, and people kind of mix and match this together in their head. But one easy way I've seen to talk about this is there's basically the human or cellular products that are your amniotic tissues, your placental products, that are often like these thin membranes that do have cells in them, like frozen, alive, fresh, or not. But one of their main mechanisms is like being this barrier on the wound and delivering the cells and the good things that are in the cells, the growth factors, the cytokines, and kind of being in a stimulatory environment. But then we have the 510K products or the animal-derived products, and they have also this huge variety in how they're processed and how they work. So like people kind of tend to maybe group them together into one group, but both the source material, many of them are like intestine, urinary bladders, like even amniotic membranes or placental membranes from animals, or skin-derived sources from bovine or fish. And the big part of this is like the three-dimensional structure of these are going to be more like a scaffold, and depending on the source material, how thick or how homologous to the human skin it's going to be. But then also the processing, and that's one of the unique thing with fish skin, especially cold water fish skin based products, is that compared to these warm-blooded mammalians like cows, cattle, sheep, pigs, they are mammals, warm-blooded like humans, and to make sure they're safe as a medical device, they have to go through harsher processing, washing out all risks of viral remnants that can be harboring in the ECM. And that makes most of these products end up with mostly being the collagen. They have some of the other active ingredients, but it's mostly just the collagen scaffold, which works great to get cellular ingrowth into it. But it lacks kind of that other bioactive molecules that might help with cell signaling or function of the tissue. And the unique thing with the cold water fish that we're using, North Atlantic cod, is that it is so distant. It's not a mammal. It's not warm-blooded. It is so distant from the humans that there's not a viral transmission risk that allows it to have a gentler processing, a lot gentler processing. Doesn't use like detergents or harsh alcohols, and that allows it to have not only the three-dimensional structure, but it also retains the fatty acids, the elastin, the glycosaminoglycans, the proteoglycans, and that really helps make it not just a collagen scaffold for cell ingrowth, but like a biologically active graft that both gets faster cell ingrowth, more vascularization, and has these added bioactive properties of the bacterial barrier and others. And that's really how we see, like, splitting out some of these products. They're mostly just bioactive, the living cell products, compared to the scaffold products that are maybe only a scaffold. But the unique thing with the fish skin is kind of taking best of both of these and having a scaffold that also has a lot of this bioactivity.
Yeah, and you highlighted last night how that matrix allows for easier fibroblast proliferation, which makes it more flexible and less scar-like as compared to some of the other products that are out there. Both for physicians and for the lay people, there have been speakers that have tried to say that because this is coming from human placenta, for example, like versus like, in a nutshell, maybe 15 seconds, tell us why that doesn't make sense whatsoever.
So, like, of course, the big thing there is, like, even though it's human tissue, like, if it's actual, like, human tissue with living cells, like, those cells are not going to survive in your body. And, like, I think no company is making that claim. Like, stem cells and everything they deliver, they all die. And, like, within, like, 6 weeks. There's, like, Apigraft, Dermagraft, and all the placental companies, they've shown those the cells, they die.
And in terms of body recognition,
yeah,
that piece.
That piece, and they like, that's foreign human cells, so they're not going to integrate into the body. But with the fish skin graft, for example, is completely acellular, so there's no like foreign reactive material, so it's a lot easier for the body's own cells to grow into it and really make it like for like, because it is skin structure, so it is actually the structure that we're trying to recreate, and getting the body's own cells to migrate into that with the cell signaling is our highlight.
Last thing I wanted to highlight is you recently had an Odington study that you're aware of. I don't know how directly you were involved on that paper, which was talking about coverage for osteo defects, more difficult areas, deeper tunneling areas. And you did this in the midst of COVID when compliance was an issue. So that's a feather in the cap of the research that your team was able to accomplish. So maybe give us some context to that and how your research continues to be the leading edge, leading the industry in ever more scrutinized data that we need to produce.
Yeah, thanks for that intro. We're super proud of the Odin study, because that was the first study that was only done on deep diabetic foot ulcers extending down to bone, tendon, joint, or capsule. And by focusing only on those, we managed to show that in these wounds that are at higher risk of getting deep infections, getting amputations, or needing intravenous like antibiotics, we managed to heal those wounds significantly faster than wounds treated with standard of care. And that's really, the baseline had been set really well by the industry in focusing on the Wagner 1 wounds, or the superficial diabetic foot ulcers that had been well documented, but there had been no real documentation on these deeper wounds, resulting in the latest LCD proposal having not included exposed bone and tendon until we published the Odin study. And by seeing the Odin study, actually Medicare added in coverage for exposed bone and tendon if you had that indicated in your IFU. So we're super proud that the study is like lifting the whole industry up, like adding that skin substitutes, when they have the right elements, can be used for these complex, deeper wounds. And that's really where we've seen the fish skin technology excel, is because of the scaffolding and rapid cell ingrowth. We're helping with these more complex wounds.
Well, I can tell you're super passionate about what you do. I thank you for the interview, and teach me a little Icelandic phrase about what would we say in Icelandic about the exuberance or the continued striving for better outcomes. Give me something here.
Áfram alla leið, læknum þessi sár.
And which means?
Go ahead all the way, let's heal these wounds.
All right, perfect. Thank you.